Welcome to Breadboarding. This is where we left the project in the last video. If you missed that video, there'll be a link in the top of the screen where you can see it in the description below. This is video 54 of the Breadboard 8088 PC, and this is part 9 of the CGA video controller. In our overall plan, we're in the final stages here, adding the CGA video controller, so you'll be able to try and run an early version of Windows 1.0 2.0 on our Breadboard PC. So let's take a look at which of the chips we're going to be wiring up during this video. So as we covered last time, we're going to be doing our blink and synchronization PLD, the control register, this is the Attribute Latch Multiplexer, the color register, the video output PLD, and the color multiplexer PLD. So those are the 6 chips we're going to be wiring up. What I'm going to do first of all is just to program them all. So I've actually sorted out all of the rules for these. So it's a lot easier to pull them out and program them when they haven't got wires all around them. So I'm going to do that first, and then I'm going to wire in the power lines and the decoupling capacitors, and then we'll start to hook in the blink synchronization divider first, and then they'll work our way through the other chips, and then we'll start to do some testing. I'm just going to clear some cables out of here, so I'm going to unplug some of the links to the other board over here, and this is the address bus. I think the upper 4 address lines we can leave there because they're out of the way. That just gives a little bit more space to see what's going on. Now, one of the things we're going to need to do first of all is the main PC decoder over here. We're going to need to pull this out and program this because there's a few changes. We've taken out the inverted reset lines from here, and there's one actually from up the top there, so we need to do those changes. And there's also a new CGA video RAM connection that we need over here, so if we don't do that, we'll forget about it. Then going to take out the various PLDs here, so this one, this one, this one, and this one, and then we'll just program those. So I'll just speed through all of that. So doing the main address decoder first, so we just need to program that. So it's just really adding the CGA RAM address, and we took out the reset off there as well. It's just finding the GED file, programming that, and then we'll just put it back into the board. There's also some changes I had to make to the reset line around there as well. So now we're doing the blink synchronization PLD. So this is very similar to the previous one in the MDA one, but we've just got an extra couple of signals there. The blank DE is the inverted display enable. So again, just program that. Put that back in. So it's a lot easier to take these chips out when they don't have all the wires around them. So this is the Attribute Multiplexer. So this again was based on the MDA one, but there's a few changes here we need to make. So the QC, QB, and all the rules to do with this were quite complicated, which we covered in the last video. So a few things I needed to change later on I'll talk about on this one. So program this. Put it back in. So now this is the video output. This is probably the most complex rule bit here. So it's based on a lot of the previous ones, but with the overscan, clear SR, or additional items, again with the delayed blink DE. So these are all the rules. I had to make 1 or 2 tweaks to these as some of the conditions here weren't quite right when I was testing. Okay, and now the color multiplexer. So this outputs the data to the DAC. So this has been changed a bit. So we're taking the colors out of the attribute multiplexer. We've also got the color register values coming there, alpha dots, and some of the control signals as well. There's an intermediate one there that just tells us when the medium res color graphics is 0 and 0. Then these are all the rules for all the various combinations that we need. So it's quite complicated, but we covered it in the previous video. And that was the color selection for the blue. And then this one I'd forgotten to compile this, so I had to compile this using WinCUPL, and we just programmed this as well. So now I need to do all of the power rails, and we'll also then need to tie some of the inputs and outputs to ground and 5 volts. So putting in all of the tie to ground and the decoupling capacitors for each of the chips. Decoupling capacitor is important to ensure the stability of the board, to reduce ground bounce, which can cause interference. And I did actually put that red line, went to ground, not to red, so I had to fix that a little bit later. So put in all the tie to 5 volts there. Sometimes a bit difficult to see at an angle when the camera's overhead. So now we're going to tie various inputs on the BlinkSync to ground and to 5 volts and wire up the display enable. So the output enable, tying the invert vertical sync, and here's the vertical sync and horizontal sync coming in. Again, I did actually swap those two, tie to ground and tie to 5 volts, needed to be swapped round later. Just taking out the reset then. I'm going to wire in the reset, and that was the display enable coming in from the CRTC. So now this is just wiring in the reset from the main bus part of the board there. Just checking those off. So now we're going to do the control register, so you need to work out where to get the data lines from. So I think I'm going to take the higher data lines from one side and the lower data lines from the other. So off of the colour register. And then we've got the enable signal coming down there, and reset we need to wire in. So CGA control is the chip enable. So just move that one out of the way for the moment. So that is the reset, going from where we just put in up to the clearing that latch there. That's the chip enable coming in from the decoder. Now we're wiring in the data lines. That'll be D5 down to D3 on this side, and then it will be D0 to D2 on the other side. Just wiring in D2 to D0 off of the colour register at the top there, where we'll have all 8 data lines going in there. Tick those off. We'll be wiring in most of the outputs when we do the other PLDs. So now this is the colour register, so that's the CGA Colour is the chip enable, the output enable. So we're just going to be putting in a cable there to drive the inputs from the CRTC there. So that is the clock which goes to the IO decoder. Output enable is just tied to ground because it's a bit tight with the power connector there. Check things off. So this Attribute Latch Multiplexer, I've been discussion about this. I had to make a few changes to it. This takes the various clock signals for the graphics and outputs the red, green, blue intensity. That's the Attribute Latch Shift Register strobe. This is the S dots, the video output. Then we need to wire in the blink enable. Then the QB and QC clock. So this gives us 4 clock signals within the 1 character for doing the 4 medium resolution graphics. Then we have the graphic enable, the clear shift register, and the attribute 7, which indicates blink. And we're just going to wire the outputs there for the red, green, blue intensity with the ribbon cable there and tick off. Now the video output PLD, we'll be doing the reset, the various blink, blank, S dots, all the various blinking cursor outputs, and character clock. Vertical sync has to go from the BlinkSync PLD over to here, so there's quite a lot going on in this one. So let's wire in reset, although I managed to make that one hole to the right, same with that one. should be the blink. This one's the blank display enable. That's the S dots. Then we need the video enable. It goes down to the control register there. Now we need to wire in the cursor and the character blink flocks. This is the cursor signal coming from the CRTC. That's the clock signal that's needed for that particular PLD. And it's used to delay the horizontal sync and vertical sync. They are delayed by 1 character clock. It's just wiring in the vertical sync, horizontal sync. Then we just need to wire in the delayed outputs from this PLD, which is delayed by 1 character cycle, over to the right hand side there. Then we need to wire in the alpha dots and the overscan output. So overscan just tells us when we're in the overscan area of the screen, which doesn't really matter with LCD monitors. Modern monitors, you can't really see it. It's only with the CRT screen we'd really see that. So now we need to wire these up to the digital analog converter. So going to take out the test connections that we had there where we were generating test colors. Wired in there the feed into P4 from the black and white mode. So now we're wiring in the blue, the green, the red and the intensity video outputs into the video DAC. And we need to start wiring in the outputs from the color register, so the red, green, blue intensity outputs from the color register, which are used for the medium resolution graphics background color and for the foreground color in high-res graphics. And then there's also the intensity, background intensity and color select is also needed. And then just plugging in the graphics control line to the control port and the 640 by 200 two-color mode enable as well, so it knows about those different graphics modes. Check those off. So there's just a few changes here. These were on the clock PLD, we just had these wired to ground or with pull-up resistors, so we just need to wire these in properly. So just going to connect the reset and the clear shift register. So that's the clear shift register and the reset going in there. And then we need the high res, which determines whether we do 80 column mode or 40 column mode. At the moment we're not enabling 40 column mode. I need to make some changes to enable that. Just check those off. Okay, so that's completed most of the wiring. There were just 1 or 2 changes that I need to make that I discovered whilst I was actually wiring everything up. So in the video output stage, we have an output from the shift register which has the serialized character ROM output and will also include the high resolution graphics output as well, the black and white output. At the moment the serial dots goes into this PLD and into this PLD. Now what the serial dots does here is it works out whether we want to show the foreground or background, and we only output the color information here. We don't output foreground and background, only the selected color. Now the problem is that this thing over here takes S dots and it takes all the cursor and the blinking information and it produces this alpha dots output, and that alpha dots actually includes the cursor information and any blinking information, and then that's actually used in outputting everything here. Now the problem is that additional information that's added by the blinking and the cursor is not in here, and so this doesn't know about the foreground and background colors. So in fact what we need to do is to feed this into here, and I did say may need S dots to be alpha dots, so I'm just going to make that change now. So we'll first change the chip. I realised we needed the plus alpha dots to make it match, otherwise it would throw up errors in validation. So just going to wire that in to the alpha dots and then copy the label. So that's made the change, so now I just need to make that change on the board. Okay, just going to disconnect the current connections between the S dots and the alpha dots, just to make a note of that it's different. So then we just need to wire in the output from the alpha dots into the attribute multiplexer, so that fixes the issue about the missing cursor and blink information, and then we're going to wire in the S dots coming out of there into that PLD. Okay, so that's that change. Now what we need to do is to plug all the various data leads back in. So this is the CRTC to colour register. So we're just going to plug this in. Now the data line we're going to feed back over to here. Since we've run out of space for the, just getting a little bit tight. And perhaps we'll feed it in here. So the data's feeding in there to here to here. We are going to have to feed it in down the bottom here when we wire up the rest of the data bus. Just wire in the address lines. It's A0 and the IO read and IO write. So IO read is the grey one. Okay, so that's down the bottom there. Now at the moment for testing, we're still feeding the CRTC address lines into the character generator here. So we're going to generate 255, 256 characters. So we need to provide some sort of video input into the attributes there. So what I'm going to do here, I'm just going to wire these up to the same address line. So it's going to give us a bit of a random jumble. Well, not random, a very predictable jumble. But it should allow us to get some test signals so we can just see if we're actually getting the variation that we expect. So this is going to need to plug into the video RAM output once I've actually finished configuring the video RAM, but this should actually do for the moment. So we now should be ready for testing. We're going to need to write a test program to set up the various register values and things. So here's the updated test program that I've done for this stage of the project. So this is testing really the character generator, the attributes and video output logic. And if you scroll down, some of the rest of it's pretty much the same, but now we're looking at the mode control register and the color register. Basically all we got is getting a key from the monitor, and I'm updating the 7-segment display with each of these test numbers. Basically each of these tests is trying different aspects out and just waiting for a key before the next one. And what I have done is summarised them here, and so basically I'll be reading off this list as we actually go through doing the tests. Now when I first started testing this, I did come across a problem and a bit of a design error on my part, and what this was related to was that on this particular PLD here, I was using a character clock to clock the data values going in here to then calculate the dot output values here, but I then realised that I really am only going to be actually changing the dots once every character rather than every dot, and so what I've ended up having to do is update the design a little bit. I've actually added an attribute latch down here, so I'm using the same latch signal that I had on that PLD, and now it's just taking the video data, latching it here, and then feeding that into the PLD here. The rest of the PLD's very similar. I've just taken out the latching components of it, and for the moment this is still plugged into the address lines on the CRTC chip here, so it's just providing values between 0 and 255 for a test pattern. So if you just have a look at the win merge on this, so there's a few changes between the original version and this one. So version 2, I changed the serial dots coming out of the shift register to alpha dots, which includes the cursor and the blink information. And then you'll see here that wherever there was the D latch used with the clock, then I've removed those. So other than that, and then the clearing, then we can remove all of those as well. So hopefully that has actually fixed that particular issue. And what you can see over here is that I've put in an extra chip down here. The input is going into over here, and then all I'm doing is taking the address lines from here into here, and there's just the latch value there coming in as well. So that appears to actually fixed the problem. So what we need to do now is to assemble the test software, download it, and then run it and see what comes out. So let's assemble this. Generate an S-record file. We're just going to switch on the breadboard PC. I just need to prepare one or two the segments for this before we actually load it. So now put the breadboard PC into load, and now we're just going to send our CGA Test for SREC file. That's finished. So now if we have a look at the VGA share, just going to run the test program. I'll check the attribute list. Now this output's going to be quite messy. It's going to have all 255 characters repeating, and it's also going to have all the various 255, 256 attribute values. So it's going to look quite messy, but we should see quite a bit of variation. So I'm just going to run up the first part of the test. So you can see in the top left-hand corner, you should just be able to see a black cursor flashing, which is good. So we have got a cursor there. And you can see that we've got mixtures of all the various colours. The foreground colours, we've got blacks there going all the way through the various colours. And you can also see we have sort of reds, greens, yellows, blues, etc. going all the way across there. I'm not 100% certain all of the palette information is still completely correct, but until we add the data buffers in, then we're not going to really be able to determine that. So the first part of the test is we're on default 80 by 25 with blink off and a white background, although the white background doesn't show due to the way how modern monitors and modern video capture cards don't bother to show anything outside the main video area. So now this next, click the key and we should now get a blink. So you can see that when it's blinking, then the background colors are more limited, that the intensity doesn't work for the background colors. But you can see there that we've definitely got blinking, and the background colors is a smaller number of the original backgrounds that we had with 16 colors. So now next one, we're going to set the black and white mode. So we should get grayscale. So this is actually simulating the composite output with the black and white flag set. So this shows us that we've got varying levels of grayscale. Now we're going to look at the 320 by 200 4 color graphics. So this is the default with the black background. Now we're going to change it to a white background. So similar colors, but the black is now white. Now changing it to have a dark grey background. So that's a little different. And now we're going to change it to color set 1. So we've got a different set of colors there. If we now set black and white mode with color set 1, we get grayscale values. Now if we set this with black and white back to 0, but with color set 1 and background intensity set to 1, so this should show a brighter version of the other one. So this mode was quite often used, I think, in a number of games and things. The colors are quite garish, but they seem to work best for CGA games. So that looks to be pretty close to what we'd expect. So then the next one is going to be black and white mode with a high intensity. So that's coming out in grayscale. And now we're going to have a look at the high resolution graphics. Now at the moment we don't have any video RAM, so what it's going to be doing is showing the character generator output, but this should show us the character generator output that we saw earlier on, but it should just be in white on black. That's great, so that looks like that's coming out okay, and you can more clearly see the flashing cursor on the top left hand corner there. So that indicates that the cursor does appear to be working. And finally, this last bit of test is just going to change the color register to a red foreground. So that's showing it in a flavor of red. I'm not sure, I think that's probably a high intensity red, that one. And then finally, we're then going to reset it back to the default. So for the moment, it looks like it's working quite well. With that couple of fixes that I did, so switching the S dots to alpha dots, and then also adding an external latch onto the Attribute Multiplexer, then that seems to have done the job. In this video, we've added these bits in orange, and then we've also needed to add an additional latch in here. And so we've got all these bits now installed and seem to be working. It's by far the most complicated part of the project. Now in the next video, in our final step, what we need to do is to actually add the video RAM and the various buffers and latches to do with the addresses for that. And we're also going to need to wire up the additional latch for handling the high resolution 2-color graphics mode. We've been able to test that mode works when being fed the character generator. But what we're going to need to do is to put in some additional logic so that when we're in the high-res graphics mode, the output of the character generator is turned off, and then we use this one, and then when we're in all the other modes, then we turn off this and we turn on the character generator. So that'll be in the next video. So I'm going to finish the video there. So if you don't want to miss out on future videos, then please hit subscribe, and if you found the content interesting, then please hit like. It just helps to make the videos available to more people. Thanks for watching.